Tonight we celebrate extraordinary engineering innovation in businesses large and small, and from the cream of our universities. The world needs brilliant engineers to address the grand challenges we face, addressing climate change, finding supplies of secure and sustainable energy, eradicating poverty and improving health and well-being. Engineering is the discipline that will design and deliver the solutions. Our spotlight on young engineers emphasizes the importance of our work with young people. We want to encourage more young people into the profession from a range of backgrounds and through new routes such as the engineering diplomas. We're contributing to the national policy on tackling climate change, security of new sources of energy, and modernizing our national infrastructure. Our aim is to create the foremost UK forum for engineering and significantly increase the profession's visible contribution to public life.
This year's finalists once again have shown the role of engineering in our everyday lives with innovations in healthcare, the built environment and the aviation industry.
The MacRobert Award is the UK's premier award for engineering innovation. It's awarded each year. There's a £50,000 prize and a gold medal to the winning team. There are three criteria: innovation, commercial success and benefit to the community. It's open to any organisation, any company of any size, for profit, not for profit, in the public sector or the private sector. This year is the 40th anniversary of the award that was founded in 1969. In that first year there were joint winners, the Severn Bridge and the Pegasus engine that powered the Harrier jump jet. I think most people will be familiar with those two projects. Most people will also be familiar with the winner in 1999, the Millennium Dome, which has since been rebranded as the O2 Centre. And then more recently, and on a completely different scale, we had the Island Hand, which was the world's first artificial bionic limb. Well, the first thing we're looking for in the winner clearly is outstanding innovation. Either the team has got an idea which is so neat you end up thinking, I wish I'd thought of that. Or alternatively, it's an idea that's been around for a long time but people haven't managed to get it to work.
The Beijing National Aquatic Centre, fondly known as the Water Cube, is the main venue for the water sports component of the Beijing Olympics last year, and will have a future life as an aquatic leisure centre for the people of Beijing. Its ambition to heat itself, to light itself, to save water, to be acoustically a wonderful environment, to be lightweight and survive earthquakes is as much a part of its character as its visual quality. The Water Cube structure is one of the most ductile structures in the world, able to absorb energy from an earthquake and keep people safe within the building. And its cladding system, using lightweight plastic, ETFE, reduces the weight of the building and therefore also helps its seismic resistance. The most important aspect of what we've done and its benefit for the world at large is not actually the building itself, which we would not like to see replicated in a way, but the tools and techniques involved in doing it. Nowadays, with the digital world, what we can do is assess the performance in what's called virtual prototyping, in a virtual world before we build something, and actually get its performance far better. So we end up with a more efficient, better quality product without spending any more time or money on designing it. It was built in 3 years, it was designed in 6 months, and is really one of the most effective and efficient construction processes I've ever seen. Arup, at the beginning of the project, supplied all the engineering disciplines, and one of the wonderful things when you do that is that all of these combine into a single outcome. So you have mechanical engineers, lighting engineers, acousticians, hydraulic engineers, structural engineers, fire engineers, communications and IT specialists, and many more. In terms of its long-term influence on China, I think it's best summed up by Hu Jintao, the Chinese president, who said that the Water Cube points the way to a better China, a more sustainable China, using less energy and providing more pleasure. For both myself and Arup Group as a whole, it is absolutely fantastic to become a finalist in the MacRobert Award. In its history, there have been very few projects in the built environment that have been either shortlisted or even awarded the MacRobert itself, and we, for our outfit, is sort of the holy grail, if you will, of engineering design.
ConjureMedic is a product that helps surgeons treat injuries to cartilage and bone using an arthroscopic procedure, which allows the body's natural repair mechanisms to heal cartilage and bone so that the patient doesn't need a total joint replacement until later in life.
We think there are probably about 50 million people who have arthritis in the UK at the moment. The number tends to increase as the treatments become more effective. And with ConjureMedic, we should be able to treat small lesions on a short stay basis, probably even a day's case. And that will mean that the patients can avoid having very expensive surgery later. The thing that's very special about this product is that it is a meshwork which is interconnected so that the patient's normal fluids and tissues can grow into the product and replace the bone and the cartilage with natural materials. This is a life-size model of a knee joint, and this is the articular cartilage. It's in this sort of region we often see the arthritis developing, and we can see that in patients by using an arthroscope, which is inserted through a very small incision. Through a similar incision, we're going to be able to repair that cartilage using ConjureMedic.
The team that helped design ConjureMedic ranged from clinicians to biomechanical engineers, mechanical engineers and material scientists. It was really a healthy mix of different disciplines coming together to create a common goal. Winning the MacRobert Award would be a very important recognition of the value of this sort of interdisciplinary research by working together with engineers, scientists, surgeons and commercial professionals.
The Tarsier system is a combination of a radar and a camera system that's been developed to scan runways for debris. What this does is minimises the number of unplanned runway closures and provides more certainty in the availability of the runway. This technology provides unparalleled sensitivity and accuracy, and that's the key technology innovation that we have here. In 2000 was the Concorde crash in Paris airport, which people may recall. The tragedy killed 113 people, and as a consequence there was a call from the airline industry and the airport industry if there were any technologies out there that could eradicate this problem from the runways. The system is primarily a radar sensor coupled with a camera system that works day and night. The radar sweeps the runway and looks for small changes, i.e. objects appearing. When an object is identified, its coordinates are sent to the camera system, which precisely focuses in and provides an operator with an image of the debris. The operator can then decide whether he needs to do something, whether he needs to close the runway or it's debris that he can ignore. But the challenge was to have a camera system that could operate day and night. We have used a laser to turn nighttime into day, but it had to be very safe and therefore a class 1M safe laser. And there's been a lot of technology innovation in producing a laser that can operate with a pointing accuracy that the radar offers. I think there's innovation going on here at every level, not only the technology innovation, not only the development innovation that was required, but also from the user perspective. This requires a huge amount of process innovation on behalf of the airport to change a practice of runway inspections that's run for 50 years, that's required them to work with the air traffic management community, the airline community and the airport community in a way to ensure that those runways are kept safe. QinetiQ is very proud to have been nominated as a finalist for this year's MacRobert Award. We find ourselves in very august company, and the sense of pride in the development team is a real reward after many years of dogged effort in developing this unique technology. Being here in the final is a reward in itself.
This is the Trent 900 engine. The Trent 900 powers the A380. The The A380 can carry up to 888 passengers. It's the largest aircraft in the industry that's a passenger-carrying aircraft. The noise of the aircraft is significantly lower than any other aircraft in its class. There's been a lot of attention to detail on the Trent 900 through advanced aerodynamics, computational fluid dynamics and design of the fan blade and the fan assembly to reduce noise, as well as the general aerodynamic design through the engine just to minimise cost, weight, performance, reduce emissions and maximise the performance of the engine, which leads to lower emissions.
The design of a gas turbine aero engine is a huge integration activity involving all engineering disciplines, both from a mechanical engineering perspective and also from an electronics engineering perspective. The key challenges in designing the Trent 900 engine were to lower the overall environmental footprint. That brings into play two issues. One is maximising the fuel efficiency of the engine, which actually delivered in the end over 100 miles per gallon equivalent efficiency per passenger. The second issue that comes into play is noise, and the key challenge was to minimise the noise for both the passengers and for the communities over which the aircraft flies. The Trent 900 has great success in the marketplace. We've secured over 53% of engine orders, and also that represents 70% of the customers that have chosen the A380 aircraft. To date, we've sold over 400 engines. Singapore Airlines has been in service since October 2007, and their quotes are it has been the smoothest entry into service that they have ever had. It's a very exciting experience, and the potential to win the MacRobert Award for me and the team represents sort of the pinnacle of our career and a very prestigious achievement.
First of all, to receive their 2009 MacRobert Award finalist certificates from Garth Morrison are Arup Group Limited for the National Aquatic Centre, Beijing. Next, Orthomimetics Limited for engineering medical implants for dual tissue regeneration. Our next finalist is Kinetic for the Tarsia Automatic Foreign Object Detection System. And our final finalist, if I could put it that way, Rolls-Royce plc for the Trent 900.
Engineering is the lifeblood of our business. We employ about 18,000 highly skilled engineers in the UK alone and have a supply chain of more than 10,000 businesses, many of them in engineering. We're very keen to support activities which promote and recognise engineering and that encourage and stimulate future generations of engineers.
What we can do and what other engineering companies can do and what the government can do, because we're all in this together, is to make sure that we continue to invest in training, in skills, in young people throughout the recession. Because the one thing you know is that at some stage we will come out of the recession, and at that point we'll really want the skills and competencies that we can help create. We think it's important to have places where people can come into a big manufacturing company at different levels. Our apprentice program is hugely important. We have 1,000 apprentices at any one time. We have about 300 a year coming into the system. Those people work on the most interesting things. So they may be working on submarines or aeroplanes or unmanned and autonomous systems in air, land and sea. They might be doing any of those things.
One project I'm currently involved with is the UK National Skills Olympics, which are held every 2 years. The competition's a nationally held event. Companies from all over the UK put forward their apprentices to represent the UK as different parts of skills. So you've got people from electronics, people from turning and milling backgrounds, and then a technician.
I really liked messing about with bikes and cars, and it was just sort of the next stage from school to come and do an apprenticeship. I'm a toolmaker and I'm working on 5-axis machining at the moment. When I tell people that I'm a tool maker, they assume that you like sit in like a dark, dirty building and make like pairs of pliers all day, and it's nothing like that at all. BA offer loads of different career opportunities. You start as an apprentice, but you don't actually have to choose what you want to be until you've done your first year of training, so you get a mixture and a broad base of all the training.
Diversity is really important. It's important at obviously the graduate entry, and as I'm sure you've seen, as you've been around the company, we have a lot of women in our apprentice program. We have a lot of women who are graduates and PhDs, and we hope in time that they will percolate up through the company and we'll have more and more women in the management of the company.
We promote schools by several means, one of which is our Schools Roadshow. We send a set of actors into a school. We do 140 schools in a year, and so over 5 years we've touched 60,000 pupils from that. We also have a Schools Ambassador programme where we encourage our young engineers to go into schools and work with the teachers on technology projects.
Engineering is the key enabler which takes all of those things, innovation and science, and delivers them to a better future for the world.
Well, our next group of award winners are the silver medalists. Now, the silver medal recognises personal contribution to British engineering resulting in market success. So please join me in welcoming onto the stage our silver medalists. They are Professor Andrew Livingston, Professor Nick Warrior, Dr. Rob Buckingham, and Mr. Andrew Graham. It's time to look at some of the engineering world's achievements over the past year and watch the Academy's best media moments.
In the past year, we have witnessed the central role of engineering in major global events and groundbreaking international scientific research. The iconic Beijing Bird's Nest Stadium, used for the opening of the 2008 Olympic Games, is an example of engineering expertise and vision. The world watched and waited for the start of one of the largest scientific experiments ever attempted, the Large Hadron Collider, that will bring new knowledge about the beginning of the universe and how it works, combines state-of-the-art engineering and science expertise, in which the UK has a leading role. The Academy continues to play its part in communicating the impact of engineering to a wide audience through the media. The Synthetic Biology Report, launched in May 2009, opened up the public debate on the benefits to society of engineering biological organisms to create new products, and was widely reported by the national press.
That's the thinking behind a relatively new area of research called synthetic biology, and a report today from the Royal Academy of Engineering argues that it's in all our interests to invest heavily in the field.
The Academy launched a diversity campaign which aims to encourage more women and people from a wide range of backgrounds into a career in engineering. It also made the headlines and a timely appearance on Woman's Hour.
Well, the answer is the solar-powered fridge designed by Emily Cummins. She's 21, a winner of awards for engineering and invention, and the kind of young woman the Royal Academy of Engineering is trying to woo into the profession.
The Academy's position on topics such as climate change and renewable energy were also reported by the national media. As news of a global recession continues to make the front pages, so does talk of how the UK can build a brighter and more stable future based on high-tech engineering. The Academy, in partnership with other engineering institutions, launched a campaign called Engineering the Future, to spread the word that engineers can tackle the big challenges facing the world and help build a stable economy for the future. At Westminster, the IUSS Select Committee highlighted the importance of engineering for the UK and called on the Royal Academy of Engineering to coordinate the profession's role in providing crucial advice to government.
Now, the next award recognises the collaboration of research with entrepreneurial promise in the field of electrotechnology.
Now, David, you're from the University of Sheffield. You work in the dynamics group there, and you've developed the ultimate suspension system for a mountain bike using your knowledge of magnetorheological fluids. I think you better tell us what that is.
That's correct. Magnetorheological fluid, essentially, it's a normal oil. You mix in some micron-sized iron particles, and when you apply a magnetic field, the fluid thickens up. So you can use that in conjunction with electronic control to develop semi-active suspension devices, for example. Some of you may be familiar with the technology. For example, the latest Ferrari motor cars and the Audi TT has these shock absorbers in them. So I'm bringing that technology to a mountain bike.
These awards recognise the outstanding work of 12 of the UK's finest young engineers, and it's gratifying to see such a talented group of young people from such a diverse background and from across a wide field of disciplines representing the future of engineering in this country.
The Royal Academy of Engineering has also nominated young engineers who have been a key part of their education activities programme and who have excelled at an early stage. This winner saw a gap in the market for using the medium of performance to help explain to a diverse audience the potential of engineering as an exciting career path. Our next award this evening is the International Medal.
We used a material what is called carbon-carbon material. This material was used. I saw in a hospital wards, children with polio patients. They were wearing the calipers, FROs, with 4 kilograms. That is a metallic. When you used the carbon composites and it reduced 4 kilograms to 400 grams. When we fitted these FROs calipers to the children, they were very happy. They were running all around. When the mothers saw that scene, they were so happy. That was the greatest happiness I got. So the highest happiness comes how you apply technology in big in a high technology area. You make a rocket, you make a missile, various system. But the technology used there when went to use for common people, that's the greatest satisfaction we can have.
Bosch has created the competition to inspire a fascination with modern technology for young people of 14 years of age and above. Our ambition is to encourage them by doing this to start a career in engineering. The Technology Horizons Award has been running for 4 successful years now, with over 1,500 entries in total. I think there are many ways of making young people more interested in engineering. One path could be to make it more visible, more transparent, more accessible, providing good examples what engineering can deliver and how engineering makes a difference to the real world. And the other one is, I think, to provide role models for the young people.
What really motivated me to enter the Technology Horizons Awards was just a way to have a look at how technology really is shaping the world today. I got involved with it after my teacher for design and technology suggested it, and obviously having work published in The Independent really doesn't hurt. The theme running through my essay was that of the battle against diminishing resources, most particularly focused on the battle for paper in schools. I think I calculated that for all 14-year-olds in the country we could carpet the country 141 times with the paper we use. The solution I proposed to the problem of the sheer amount of paper used in schools was a greater focus on electronic equipment, for example notebooks and e-books.
The national curriculum at the moment offers opportunities for students to study design and making and focusing really on products, and what we really want to do is offer a broader perspective for students and push their own thinking more with the competition, and that's what the Technology Horizon competition does. It allows them to express a more global perspective on their education.
Reducing the CO2 footprint provides a lot of challenges, but also important opportunities for industry. There are renewable energies from water to wind to solar. In March 2008, building began on the new manufacturing facility for the Bosch Solar Energy division. Here they make crystalline cells and modules. In 2008, Bosch invested in total 3.9 billion euros in research and development, and in fact more than 32,000 Bosch employees are working in the field of R&D. This year's competition has seen another record level of entries. Not only that, but also the quality was outstanding. That means the two winners should be really proud for what they have achieved. And I'm really looking forward to follow their career, perhaps a career in engineering.
In the 14 to 18 age category from Urmston Grammar School, Manchester, Leon Zhang. Well done to him. The winner in the 19 to 24 age category is from Cardiff University, Gavin Harper. The next award is in memory of Sir George McFarlane, one of the founding fellows of the Academy. It recognises the potential of younger UK engineers who have demonstrated excellence in the early stage of their careers. Please give a round of applause to this year's winner, Dr. Silvia Schiavano. The President's Medal. This is awarded annually to an organisation or individual who has contributed significantly to the Academy's aims in promoting the highest standards in engineering. Our winner of the President's Medal is Sir Alan Rudge. Well, the waiting is almost over for all the teams as we reveal which of them will go home tonight with the Royal Academy of Engineering's MacRobert Award 2009.
The winner of the 2009 MacRobert Award is Arab.